So when we're looking at periodic data, before we get there, let's kind of take a look at some of these things I've got for situations and see what they might have in common. So we've got a pendulum. Now, if some of you you're like, what the heck's even a pendulum? If you have any like grandparents maybe that have those older clocks that kind of swing back and forth with that arm at the bottom, that's what a pendulum is. The average temperature each month in Texas, a heartbeat, and the time for high and low tide when the waves are way up, way down each day. What's something those could all have in common? It kind of sounds like one of those questions I do on the goofy ones sometimes.
I feel like, wait, are you asking us?
I am asking you, yes.
What is like a heartbeat and the tide below?
They kind of, yeah, they have some highs and lows. Okay, so we may have highs and lows, but we also may have a motion or an action that repeats. So basically, when you see a pendulum swing, it just keeps going back and forth at the same type of thing. Your heartbeat, most of the time, is pretty consistent. Now, if you're getting all fired up, it may go up for a while, or if you're really calm, it may, kind of slow back a little bit. But we see this repeating pattern. So are there any other patterns that you could think of? What's that? Okay, anything, right, where you're seeing some sort of a fluctuation or an adjustment within time and period. So we could have just anything. I had to stop and think for a minute. I'm like, how do I spell this again? Okay, or if you're going back to the things in the medical things, you may have your pulse rate. Okay. Some of you may have some other things that you just do at the same time every day. Some of you maybe go to bed at the same time every day, or you have work hours that are the same each day, each week. But wherever you can see a pattern, okay, that's actually what periodic data is going to be. So
we're starting to add logic into this.
Well, that's just kind of so we can make a connection on what this is. Because we're going to actually bring it back to the trig, but not quite yet. This is kind of our intro, our baby step to get us there. So, we have this thing called a periodic function. And it just repeats at regular intervals. I mean, the best example really where you can kind of visually think about it is the heartbeat. If you look at those monitors and you see the lines that are going up and down with that, and if it's consistent for a while, you keep seeing the same pattern repeat and repeat. And so, speaking of patterns, we've got this thing called a cycle, which is when a pattern starts, and then it gets back to the beginning and starts again. That's one complete cycle. And that's the word that we use to call that. And then if we know how long the cycle lasts, that's called a period. And again, normally we just use that term when we're talking about a trig function, which we'll get into a little bit later down the road here. But we call the length of time a period, and the pattern itself a cycle. So here's why we've got the colored pens that we're working with here. As we start looking at some of these cycles, okay, at some of these patterns, what we're going to do is we're going to analyze them, okay? When it says identify the cycle in two different ways, basically first I got to look and say, okay, where does one of these cycles start and end? So one of the ways I can do that is say, okay, so this one, like, let's say this one starts here. And then, okay, so let's see, how's this work? It goes up, it goes down, it goes over, it goes down, and then it goes back to that line again. So it looks like this one goes from here to here. So how long is that cycle? What's the period of that cycle? I go, okay, let's see. 1, 2, 3, 4, 5, 6. And it just goes 7 units. Oh, not having luck with the pens. So then, it doesn't just mean that's the only place that I can look for that particular pattern. So let's say you didn't look at the bottoms. You said, hey, I'm going to look up here at the tops of each of these and do it that way instead. Would I get the same answer? Well, hopefully. So 1, 2, 3, 4, 5, 6, 7. So I also get that same 7 no matter where I'm at. And I have had people before that instead of maybe doing the dots like to actually put like a sectioning line off there saying this is where my pattern starts and ends, and then it's easier to count. But there's lots of places within this cycle that I can figure out how long the period is going to be. Okay. So that's how I can identify the cycle in 2 different ways. Pick a beginning and ending point and then count how far it is between. And then what is the period? Well, the period is 7. That's how long this particular cycle lasts. But like I said, you've got lots of choices with these on where you're going to start and where you're going to end. So maybe you look at the next one, and I'm always kind of biased towards using the ones at the very top or the very bottom because that seems to be where the most obvious. So maybe I get here and I say, okay, you know, these 2 guys, and they're 1, 2, 3, 4 apart from each other. Or maybe then I just go to somewhere completely different in my pattern. It doesn't matter which place. Thank you. So let's say I look and I say, okay, I'm going to go from this point to this point. I want to find that same spot in my pattern. And I go 1, 2, 3, 4. But again, I want to show 2 different places where it's at. So whether you mark the end lines, whether you decide you're going to highlight the whole thing by kind of doing this to show what the difference is, I'm fine with you doing it either way. When you're doing it on a worksheet, that's easy to show. When you're doing it out of a book assignment, maybe you'll want to resketch it, or maybe you're going to be able to eyeball it at that point. I don't know. It just depends on how you're going to decide you're going to tackle that. So that's one thing. So if I tell you it's periodic, it tells you there's a pattern that's involved, and we're going to find that pattern. But what if you're not sure? What if you flip over and you're like, is this a periodic function? You've got to see the same exact pattern happening over and over. So when I look at that on this first one, on number 3, I don't see the same pattern. Now, some of you may say, well, what do you mean? I mean, it keeps crossing the axis here. Sure, but is it going up the same amount each time? No, it's kind of squishing and getting smaller and smaller. Okay, so this first one is not periodic. And you may have a different way of explaining this than I do. Let me explain why I'm doing it this way. I'm going to say that the vertical value is not consistent. Or you could say it doesn't go up and down the same amount, if you wanted to call it that way. Because here it goes way up here, and then it's not so high and not so high, and it's not the same as I'm looking through. However, if I look through it, I'm like, okay, can I find a place where it's the same all the way through? And I'm like, well, wait a minute. If I went from here to here, it goes up, it comes down, and then it starts and it does the exact same pattern again over to here, yeah, that's periodic. Yeah, I can count from here to here, 1, 2, 3, 4, 5, 6, 7, and count again, 1, 2, 3, 4, 5, 7. And if I see that pattern's the same, and even if I wanted to, I could do it up here at the apex or at the peak of each one. 1, 2, 3, 4, 5, 6, 7. So yes, that one definitely is, and its period would be 7. Because no matter if I did it at the top or the bottom, I see that pattern. The pattern goes, and then it starts over again, and I keep seeing the exact same thing. And that's going to be the key. So that kind of gets us going on what a period is. How long does it take to get a complete cycle? So there's one other part that kind of goes along with this, and it's figuring out some of the other vocabulary or some of the other parts of this that we can find. So the two other little terms we're going to discuss today are called the amplitude, which basically is letting me know how high and how low throughout my cycle or my value is going to go. So it's half the distance between the maximum and the minimum values. So I find the highest value, I find the lowest value, and then I cut it in half. That'll tell me what my amplitude is. Then my other one is what's called the midline, and it's exactly what it sounds. It's the middle of my max and min. So it's real similar in what they are. The only difference is it plus or minus that's going in the middle. And we'll draw these in too so you can kind of see how this works. So if I have a periodic function, and I have to have a periodic function to have an amplitude and a midline, what's the amplitude of the middle? Well, I got to find my max and my min first. So I look around and I'm like, okay, this seems to be where it's highest. So that's 1, 2, 3, 4. So it looks like my max is at 5. And then I look around for my lowest point. Looks like it's down here. 1, 2, 3. So my min is at -3. So now I need to find these two values that I'm looking for. So my amplitude is going to be 1/2 my maximum minus, now this is where I've got to be a little bit careful, minus my minimum. I'm minusing a negative. It's not just 5 minus 3. Okay, so what happens when you minus a negative? Yeah, that's going to become positive. So it's 5 plus 3, or 8. So my amplitude is going to be 4. Now, that'll be a little easier to see here in a minute because we're going to figure out what the midline is. I'm going to draw it in so you can see what this amplitude thing is, how it works. A little bit different when you're talking about music, we're talking about amps, even though there are some connections with music here too. Okay, so my midline, same formula except now it's a plus in the middle. So 1/2 of 5 plus -3. Well, 5 plus -3 would be like 5 minus 3. So that would be 1/2 of 2, or 1. So I'm hoping here in a minute when we draw this in, it's going to kind of make a connection on how these two things work together. So my midline is at 1. So if I were to draw my midline in, okay, basically what that does is it's going to split the middle of my function. And then what the amplitude is from the midline, how far is it to get to the top or the bottom? Well, to get from 1 to -3, it's 4 away, my amplitude. To get from 1 to 5, how far am I away? 4, my amplitude. So that's how those two things kind of come together. Okay? And that's something, again, when we get into the trig functions, that's going to help us to make expressions and to make equations and to kind of see where the patterns are developing. But we got to work this before that so we know what we're doing once we actually start doing those things. Okay. 6. I'm hoping to get some help this time. We'll see how this goes. What's my maximum value on number 6? 8. Okay, and you can pick any of these max points. Let's say I pick this one. All right, so my max is 8. What's my min? 0. So again, now that I've got those two values, and if sometime you look and you're like, well, wait a minute, my max is different here than here, then it's probably not even periodic and you don't even do any of this stuff. So my amplitude would be 1/2 of 8 minus 0. 1/2 of 8 is 4. And no, it doesn't mean it's going to be 4 every single time, just because it has been on the two examples. My midline, same values, except instead of subtracting them, we're going to add them instead. You're like, well, wait a minute, 1/2 of 8 is still 4. Can they be the same thing? Sure. Because once I draw that in, and I'm a fan of drawing the midline in. So 1, 2, 3. Because again, I can always look once I draw that midline in, because it should be going right down the middle of my function. How far is it to get from here to the max? 4. How far is it to get from here to the min? 4. They should be equal every time. If they're not, I didn't do something right with my calculating. So here's what your job with this is going to be, to kind of see how this works. And some of you may feel the need to draw these. I'm even going to pop the book up here for a second so you can see how this works. So the assignment's back here at the front. Now, it seems ridiculously like a lot compared to me for most of the time, but when I show you here in a minute what you're actually doing, this isn't gonna be too terrible. So let me flop the book on here for a second so you can see what you're in for. So basically what we're gonna do is it says identify one cycle in 2 ways. This is like what we did on examples 1 and 2. Find a spot where the pattern starts and then where it ends, and count how far it is from one to the other. Okay, so that's all you're doing. Find those 2 cycles and then determine the period. So maybe on this one, if you don't want to redraw it over, you say, okay, my pattern starts at negative, let's see, these are counting by 2, so my pattern starts at -4 here. Yes, I'm going to do the unthinkable. I'm going to mark in the book. Don't you do this. And then my pattern doesn't end here. It ends here, like at 1. So maybe you put -2 to 1 is one place, and then you look and you're like, well, this is the top, so it starts here, down, over, down, back, up, and you mark it. Oh, it's this amount from here to here, and it should be the same. That would be your period. So if you want to be able to draw it, you can draw it. You can make a quick sketch on a piece of paper, but otherwise just telling me, you know, what the values are that you counted from is fine. Okay. When you get to the next part, determine whether the function is periodic or not. Is the pattern the same as you're going along? If it is, that's fine. You can go ahead, you can do that. But if the pattern isn't repeating, and little things can make it different. Okay, 13, it doesn't go down as much. Okay, yeah, that's not going to work. And you kind of can look. Even here, it may look the same, but it's going downward. It's shrinking. Probably isn't going to be 1. Okay? Right, or 12. 11 looks like we have some possibilities that it could be a function that's periodic. 14 looks like it could be periodic. 15 looks like it could be periodic. And I'd have to find that. But if I see any inconsistencies in the pattern, not going to be periodic. And then find the amplitude and midline. Okay, we know how to do that. We've done that. And that's basically the 3 things that you're doing for these. And that's it. So it's nothing that's going to be too terribly awful that you're going to have to work through with that. So, again, play with these. Take copies. Take pictures of the pages if you need to. Work through with that. You've got plenty of time to get a good start on this and make sure things are going well. And again, we'll be doing some review stuff for the last quiz tomorrow.